Okay, today we're going to look at 4 different theorems involving chords and circles. Remember, a chord is any segment that has endpoints on the circle. Alright, first one. If a diameter is perpendicular to a chord, then it bisects the chord and its minor and major arcs. Okay, well the conditional part of this is that it's a perpendicular. So let's look and see. It says right here angle AEB is 90 degrees. So these two segments would be perpendicular. BD is the chord, and notice if I take D and grab it and move it, the angle AEB always stays 90 degrees. Alright, now let's look at the then part, the conclusion. It bisects the chord. Okay, does GC bisect the chord when it's perpendicular to it? What's at 90 degrees? Let's see. BD is 9.89, BE is 4.94, and ED is 4.94. And that's off just a little bit because the computer rounds these numbers. But when you add BE and ED together, they are equal to ED. So yes, it does bisect it. Let's look at the minor arcs and the major arcs. Remember, a minor arc is less than 180 degrees, or a semicircle. So BD, arc BD is a minor arc, and BC is cutting the minor arc in half. So BC is congruent to CD. Also, the major arc is bisected. The major arc would be BGD. And you'll notice that BG, arc BG on the top part, and arc GD on the bottom part are equal to each other, so they're also bisected. Next theorem, if a diameter bisects a chord that is not a diameter, then it is perpendicular to the chord and bisects its major and minor arcs. Alright, so here we have a diameter CD that is bisecting the chord FE. How do we know it's bisecting the chord? Well, FE and FG are congruent to FG and GE are congruent to each other. So G must be the bisector. Is it perpendicular? Well, right here we have the measure of angle BGF, and no matter where I move this chord, it always stays 90 degrees. And if you look at the minor arc, FE, it's being bisected by point D. And the major arc, FCE, is bisected at point C. So FC and CE are also congruent. Notice that when I move this, all your relationships stay the same. It's always 90 degrees, and you always have your bisectors. Next theorem, perpendicular bisector of a chord contains the center of the circle. Alright, if the chord here is FE, the bisector would be CD. It's perpendicular. Angle BGF makes a 90-degree angle, and it's a bisector because FG is congruent to EG. Now, how do we know it's the center? Well, let's take this point E and move the chord around. Notice the distances BF and BE right here. Do these distances ever change? No, they don't. And there is only one point inside a circle that is equidistant from all the points on the circle, and that's the center. Okay, so point B must be the center. Alright, next one, theorem. In the same circle or in congruent circles, congruent chords are equidistant from the center. Now remember, how do we measure distance? Distance has to be the perpendicular distance between two objects. Here the center is a point B and the chord is FG or ED. Notice the angles BCF is 90 degrees, and angle BHE is 90 degrees. So they're both perpendicular to the center. Notice the distances right here are congruent, 4.64 and 4.64. The chords are congruent. So let's move this around and see if this relationship holds true. Let me grab point C here. We can rotate it, we can move it in, we can move it out. Those chords are always the same length. They're always the same length, so they're always congruent. The angles always stay 90. BC and BH, the distance between the chord and the center of the circle, is always the same no matter how I move this. Okay? Those relationships always hold true. Alright, last theorem. In the same circle, or in congruent circles, chords equidistant from the center are congruent. This is just the flip or the converse of the last theorem. Let's say you have congruent chords, or I'm sorry, you have chords that are equidistant from the center. So CB is the same as CD. Are the chords going to be congruent? Well, EF, chord EF, and chord GH are congruent. So let's take this point B and move it around. This is basically the same picture as before. No matter how I move it around, as long as those chords are equidistant from the center, they are congruent. Alright, the next video you watch, we're going to work some problems with these, and then we're going to do another video will have some proofs of these theorems. So good luck with this stuff. If you have any questions, don't be afraid to ask.